Hi, let's continue our discussion on implementing logistic regression. By the end of this video, you will be able to evaluate logistic regression models using evaluation metrics. Let's start with the most basic and the default metric of logistic regression classifier, accuracy. For this, we simply call the classifier.score function and pass the test set as parameters in the dataset churn prediction simple. On running this cell, the accuracy score of the model comes out to be 0.72. We built a minimum viable model and it is performing fairly. But if you remember, the data is imbalanced, hence we should check the precision and recall. Now, let's shift our focus to calculating the precision score of the model. For this, we will import the precision score function from sklearn.matrix module. As this is a function, we can use it straight away. We will use this function and pass the true values ytest and the predicted values and will store the result into a variable called precision. On running this cell, the precision score comes out to be 0.37, which means 37% of the observations have been predicted as false positive. Now let's look at the recall metric. The process of calculating recall score again is a very similar process as that of calculating precision score. We will import the recall_score function from the sklearn.matrix module. We will call the recall score function and pass the actual values and the predicted values to it, and we will be storing the result in the variable called recall. On running this cell, the recall score comes out to be 0.63, which means that out of all the actual positive observations, only 63% of the observations have been predicted as positive. Now, choosing between precision and recall is again a matter of business problem. Suppose we want to retain the customer who is churning. For that, we may introduce offers or gifts from the bank which might help the customer to stay. In this case, we should be looking to maximize the recall as we are okay with false positives. That is, sending a gift to someone who would not have churned anyway, but the model falsely predicted that the customer would churn. On the other hand, if the offer or the incentive which we are providing is very expensive for the bank, like an Apple Watch, in this case we will have to be critically choosy as each gift to a customer will cost us. As a result, we would prefer precision over recall in this case. Now again, we do not know which metric we should use in this problem, therefore F1 score should be considered. And we can recollect from the previous videos that F1 score is the harmonic mean of precision and recall. As we already have the values of precision and recall, let's calculate the F1 score. We will simply feed the values of precision and recall which we calculated earlier in this video into the formula. On running the cell, the output comes out to be 0.47. Now, but as you can already guess, we can calculate this using the predefined functions too. For that, we again import the F1 score function from the sklearn_matrix function, and just like before, we will pass the ytest and the predicted values. On running this cell, the output comes out to be 0.47, which is equal to the values which we calculated manually, which means everything is exactly with respect to the class 1. But our model is far from a good model as the F1 score is less than 0.50. Let's see if feature engineering can help. We have been importing so many functions from the metrics module of the sklearn. What if we can get all the metrics at once? For this, we import the function called precision recall f_scores support as prf summary. We call this function and pass the ytest and predicted values. An important thing to note is that we are using 4 variables, that is precision, recall, f1, support, to store the result as this function returns 4 things at once. Now there is something new here. We have not seen the support so far. Now what is support? Well, support is nothing but the number of instances for the class 1 and class 0 as seen in the train target labels. Now let's print each of these variables one by one. We can see that there is something different here. Each of these variables has 2 values stored in them. Can you guess why? The precision recall f-score support function returns the metric with respect to both of the classes. In our case, there are only two classes. Therefore, two values corresponding to precision recall and f1 score. Therefore, the first value represents the metric score with respect to class 0 and the second value for class 1. The function we just discussed is a great way to quickly calculate the evaluation metrics for any classification model. But the representation of these metrics is not very intuitive, as this only outputs a bunch of numbers which is very easy to get lost in. As structured representation can be very good for quick insights, we can look at another function which exactly does the same. For this, we will again import the function called classification report. We will call this function and pass the actual values in ytest and predicted values. On running this cell, we can clearly see the representation of the precision, recall and f1 score with respect to both class 1 and class 0. The drawback of this function is that we cannot use the values displayed in this function, as this function is only meant for representation purpose only. Now, in the previous videos, we discussed that precision and recall tend to have a trade-off between them. So let's try to visualize it. For this, we will import the precision underscore recall underscore curve from the sklearn matrix. When we call this function and pass the actual labels ytest and the predicted probabilities from the classifier model, it returns precision values, recall values, and threshold points. What this function does is that it calculates the precision and recall for every threshold possible between the probabilities 0 and 1. As the threshold value changes, the corresponding values of the precision and recall are stored in a list. When we print the shape of all these three lists, we can see that the list of threshold points is shorter by one value. As a result, we will skip the last point from precision points and recall points while plotting the precision recall trade-off curve. Now that we have the precision and recall list for the different values of the threshold, we will now plot them. For this, we will plot the threshold points on the x-axis and the magnitude of the precision and recall on the y-axis, as you can see in line 2 and 3 of the code. On running this cell, we can clearly see that precision and recall has the trade-off relation which we discussed. As the precision of the model increases, the recall of the model decreases. Although the performance is not great, we can infer that the intersection point is somewhere near 0.55 threshold, which should be a great threshold for the maximum performance of the classifier model. So that's it in this video. In the next video, we will discuss the AUC ROC curve. See you then.